All right, today's lesson is on quadratic vertex form word problems. So we've been looking at the vertex form and graphing it and looking at where the vertex is and just finding lots of different information. But today we're just going to, connect it to some word problems and just solve our way to some uh, like questions like if we throw something, when is it, how long does it take to drop back to the ground, or um, yeah, like, or if I say, like, if 5 seconds in, how high is it in the air, and so forth. Okay. All right. So we'll start off with example one here. So we have someone dropping a tool off of somewhere, and here's the equation that represents the tool falling in the air. So the h is going to be the height above the ground. T will be the time that it takes for the wrench to drop. Okay. All right, so the first question here is I want to know after 5 seconds, so like at 0 seconds, he let go of the tool and started falling. So at 5 seconds later, whereabouts is the tool now in the air? Okay, I'm going to start off with just writing out the equation that we were given. So we have the height equals negative 4.9 t squared plus 242. Okay. All right. So they want us to figure out at 5 seconds how far did the wrench fall. So they want us. So okay, you can think of it as like so at a time of 5 seconds, they want us to tell them what height the wrench got to. Okay, so I'm going to graph this in decimals just so that you can kind of visually see what's going on with this problem. I'm just going to make a rough sketch of that graph on here. So you can just kind of look at it like, okay, so the worker was sitting up here and made a mistake and then dropped the wrench, okay, off the building or wherever he was standing. All right, so we want to know, so this is the time that's going by, and this is the height of the building or wherever he's standing, and we want to figure out, okay, at about 5 seconds, which is, I don't know, like say right there, how high is the wrench? That's what we're trying to figure out. Okay, so what we're going to do here is we take our equation that we have, and we're going to plug the letter that we know right into the equation here. So if we write this again, I'm going to put 5 in for t. Okay, like that. So we're replacing the t, everything else stays the same, the square is still there, 342. Okay, so now I just want you to go through, now that you subbed it in, calculate it out. So follow BEDMAS. BEDMAS is brackets first. Nothing we can do in the brackets. Okay, let's do exponents next. So that'll be 5 squared, which is the same as 25, like that. Okay, so BEDMAS will say, all right, so brackets, exponents. All right, exponents are done. So now we have to multiply. So we're going to multiply these two together. And we'll get negative 122.5. And then the 342 as well. All right, and then last step, add them together. Or, so negative 122.5 added to 342. And you end up with positive 219.5. Okay, and what is this? This is the height. Okay, so at 5 seconds, the height of the wrench is 291 meters in the air. Okay, all right, so if we're trying to figure out, well, how high were we before the wrench dropped, we can take a look at our decimals graph here. So we zoom in here, look like we're about 341, I guess, 342, 342. Oh, yeah, so like if you look at the equation here, it's 342, so that's the y-intercept. All right, so we're about 342 meters in the air, so we could even jot that down. Okay, so 342 meters in the air, and then it was dropped. So 5 seconds later, it is now 219.5 meters in the air. So now we know that the wrench is about here. Okay, and that is now 219 meters in the air, okay? All right, so if you look at the question, how far has the wrench fallen? So how far from here to here did it fall? That's what we got to figure out. Okay, so just do one more calculation here. So we know we started at 200 or 342, and again, you can find that just by looking at that constant value here. It tells you where the y-intercept is, okay? And so here, that's the y-intercept. All right, so we take that number and the number we just found and subtract it, we will find that it fell 122.5 meters so far. Okay, so 5 seconds later after you dropped it, it's 122.5 meters down from where it used to be. All right, so make a therefore statement. For with these 3 dots, the wrench has fallen 122.5 meters. Okay, all right, so there's the first part done. Okay, let's try the second part now. All right, so part B, when will the wrench hit the ground? Okay, so we are trying to figure out, now using our little sketch here, where does it get to, when does it get to the ground? Okay, so here's the ground, it hits right there, say. Okay, so what time was that? How many seconds later was that? Because we know about here was 5, which again, this isn't to scale, and it's this graph is just a rough sketch, but we know like here was 5. So there, when it hits the ground, it crashes into the ground. How many seconds later was that? That's what we got to find. Okay, so here's the scenario. You have this equation again. And I want to know when it hits the ground. So what's the height? Okay, because I knew the time last time, but I don't know the time. But I know the height. When it hits the ground, what would the h value be here on here? Okay, so when it hits the ground, you'll be right here, right? And that is 0. That's 0 right there. Okay, so we know the height. When the height is 0, okay, what will the time be? That's what we got to figure out. Okay, so we're going to do the same thing we did there. We're just going to plug some numbers in where they're supposed to go. So this time we know that the h is 0. So that's what we'll plug in. So let's do a different color here. So 0. Okay, we'll take out the h, put a 0 in its place, and then we have everything else here. All right, so if we can figure out t, we need to solve for t. If we can figure that out, we can figure out the time. Okay, so this is going back to like the first cycle where we learned to solve when we had squares and square roots and so forth. Okay, but remember, follow Sam Deb. Okay, so we're going to look for anything adding and subtracting first. We're going to move anything multiplied and divided next. Then we'll do the exponents, okay, or you can think of it as the square roots as well, and then we'll do the brackets. Okay, so if we're looking at t here, all the things stuck to t is the negative 4.9 stuck there, the exponent 2 stuck there, and the 342 stuck there. So the first one we're going to move is the number that's added or subtracted, so that's 342. So let's boot it over here. Okay, so right now it's plus 342, so it becomes negative 342 on that side. Okay, all right, and then now we have the exponent and we have negative 4.9 multiplied onto t. Okay, so the next thing, so we've moved that. The next thing is the multiply divide. Okay, so we have to move this first before we move the exponent. So let's boot that over. So see how it's multiplied onto t. When you boot it over, it's going to divide the negative 4.9 over there. Okay. So when you get to there, divide those out. So negative and negative will make a positive. And then you get to 69.795, etc. Okay. So let's carry a few extra digits here. I think there's another 9 here. okay, equals t squared. All right, we're almost there. Now we have to boot this exponent 2 over. Okay, so what's the opposite of the exponent 2? You square root the other side. Okay, so if we square root that, we'll get t equals 8.3543, etc. Okay, so we are trying to figure out how long will, like what time will pass when the wrench eventually hits the ground. Okay, so again, we were up really high up on this building here, and the wrench slowly dropped through the air, hit the ground there. We were trying to figure out how many seconds that would take. So we found it was, and like we could just run it to a couple decimal places, I guess. We found that it was 8.35 seconds. Okay, so let's write our therefore statement. Therefore, the wrench will hit the ground at 8.35 seconds. Okay, so again, we've been practicing solving a lot all the way through the year, and now we're actually able to apply it to the word problems. Okay, so again, and we were plugging in stuff in, watching our bed mass, watching our Sam Deb, and going through and solving the problem. All right, so be able to do those, and let's move on to another one here. Okay, so we have a football player, kicks a football. Football reaches the maximum height of 30 meters, and it travels a horizontal distance of 18 meters. Okay, so if we're trying to make a rough sketch, we can even do this in Desmos too. Whoops. We could just kind of, yeah, like a rough sketch to visualize this. So, sorry, the ground's supposed to be flat here. Okay, good enough. All right, so we have, so say the football player starts, the ball's here, kicks it up, okay, and then it falls to the ground, okay? So it's just saying that the football gets as high as, 30 meters when it's 18 meters from where he kicked it, okay? And then, anyway, this is the equation for the path of the ball. All right, so I want to know what horizontal distance is it when it hits the ground right here. Okay, so I want you to go through and solve that problem. So again, you have the equation. Whoops, it's y this time. So we have y here, we have x here. Here's the equation. So again, what is the height of the ball? Remember that that's y when it hits the ground. Well, y is equal to 0 at that point. Okay, so right here, y is equal to 0. So we want to know how much time did that take, or no, how far is that across the field? So we need to figure this out here. All right, so we need to figure out the x. So let's plug the 0 in and solve our way out. Okay. All right, so same thing again, you use SAMDEP. All right, so we're going to move 30 first, so anything added or subtracted moves first. So it's plus 30, so it becomes minus 30 over here. Okay, the next thing SAMDEB says is anything multiplied or divided, so we can move this one now. And that leaves this here. Okay, so I'm just going to take care of that 30 divided by 0.091. Both of them are negative, so it should be a positive number. So you end up with 329,670.3. I'm just carrying a few extra digits here. All right, and then SAMDEB says, remember, do the exponents first before you touch anything inside the brackets. All right, so we're going to move the exponent 2 that way. So whenever we kick an exponent like squared across to the other side of the equal sign, you end up square rooting the number that's there. Okay, so then you're left with x minus 18, but you can just drop the brackets, right? So it's just like that. Anyway, let's just square root that. And we get 18.1568 equals x minus 18. All right, so now we can deal with the brackets. Now we can move this 18 out of there. So we're going to add it on that side. Like that, okay. So add 18, and then we get a total of 36.1568, etc. Okay, and this is meters because we're trying to figure out how far down the field. Okay, some of you may have tried to guess, oh, it's 36 exactly, but that ends up being a little bit more than 36. Okay, so does it say how many decimal places? No. All right, so let's just say 36.2, like that, meters. Okay, so therefore, okay, they want us to know the horizontal distance, the ball. At what horizontal distance does the ball hit? Okay, so the ball hits. So it hits the ground at 36.2 meters. Okay, so assuming we started at 0 when the ball was kicked. All right, so be able to do questions like this today. Okay, so when I give you a checkpoint, all it is that you do is you take your equation, and if I give you one of the letters, just plug it in. So I'll give you one where I'll give you the letter that's already in the equation, and you have to solve for the H or the Y, okay? And then I'll give you one where I'm going to tell you the Y or the number that's out here, and you have to solve the one that's in here. So one of them you have to use BEDMAS. So like this one up here, you use BEDMAS, okay? Because you didn't have to solve, you just had to, calculate. You just had to calculate the answer. But here, I gave you the answer was 0. You had to use SAMDEB. Okay, so use SAMDEB to solve your way through. And I'll even kind of prompt you with the checkpoint. Okay, hint, make sure you use BEDMAS here. Hint, make sure you use SAMDEB here. Okay, all right, so that's it for today's lesson. Be able to do these word problems here.